Solving multi-step equations. So now we're going to look at equations where instead of just one step to isolate the variable, we need to do more than one step to isolate the variable. So we're going to start looking at all of those operations, adding, subtracting, multiplying, and dividing, kind of coming at us all at once. So again, we want to think about kind of undoing our order of operations. We want to look at parentheses first, simplify our parentheses, deal with any exponents, and then we want to work backwards here. So instead of multiplying and divide first and then add, subtract, we want to get rid of adding and subtracting first and save the multiplying and dividing to the very last step. Get rid of that last as far as we go. All right, so we have this expression, we have this equation, 2x plus 1 equals 7. Again, don't forget that the middle of our equation is that equal sign. So if we think about that balance, the equal sign is right in the middle of them. Even if one side looks like it has more, they are equal to each other. So 2x plus 1 is equal to 7. It looks like it has more, but it's not. It's the same amount of stuff. So we don't have any parentheses here. We don't have to worry about that. We don't have any exponents. We don't have any like terms that we need to combine over here. 2x plus 1, they're not like terms. 7 is all by itself, so there's nothing exciting to do over here on the right. So what we're going to start to do is get that variable by itself. So I'm going to get rid of the adding and subtracting first. That's going to be my first step. So I want to get the x by itself. That's my goal. I'm trying to get this by itself. So let's first get rid of whatever we're adding or subtracting to that x. So we're adding a 1, so we're going to do the opposite. We're going to subtract 1 from both sides, that both sides still say equal as we go. So that gets rid of my 1 on my left-hand side and leaves me with 2x. On my right side, that leaves me with 6. Notice the x is not by itself yet. I still have this x here, and it's got multiplied by a 2. So this is going to be our last step to get rid of the multiplying by 2. To get rid of multiplying, I divide. And we're not going to use that division sign anymore. Remember that? We're not using that line with the 2 dots. We're just going to use a fraction bar. So we're going to put that fraction bar with a 2 underneath it, which cancels out these 2. So I'm multiplying by 2, dividing by 2. Those kind of cancel each other out. On my right side, I also divide by 2, which gives me 3. So x is equal to 3. So if I go back up into my original and I think about what would happen if I put 3 where the x is, I get 2 times 3, which is 6, plus 1. 6 plus 1 is 7. Perfect. All right, next one. I've got negative 4 plus x over 9 equals 5. So again, my equal sign is the middle of my equation. That's where my two sides are. No, I don't see any parentheses, so I don't have to deal with distributive property. I'm looking for like terms here. I see an x here, but this one does not have an x, so I can't combine these. And my right side just has a 5, so there's nothing to combine. All right, so now I'm going to deal with my adding and subtracting first. I'm going to get rid of those first. So here I am adding a negative 4. So to get rid of adding a negative 4, I'm going to have to add a positive 4. So I'm going to add a positive 4 to both sides, because this negative 4 and this positive 4 will now cancel each other out. That leaves me with x over 9 on the left, and on the right side I have just plain old 9. So here I have x divided by 9, and to get rid of dividing by 9, I'm going to multiply by 9. So here I'm going to multiply by 9, and I've got a fraction, so we can think about this like multiplying by a fraction. And again, if I was multiplying with fractions, this would simplify out, and those would go away. That's the whole point here, that we're getting rid of that 9 in the denominator. That leaves us with the x, and then on the right side, we have 9 times 9, which is 81. All right, so we're kind of adding all 4 of those operations all together. We've got to figure out which one to do first, which one to do last. Again, save that multiplying and dividing until the very last. All right, one more. Oh, we've got some parentheses. So 6 and then parentheses y plus 4 equals negative 18. So again, notice that my equal sign is the middle of my equations. What's on the left and what's on the right, they're still equal to each other, even though this left side looks more complicated. Parentheses. So let's deal with the parentheses. Y plus 4. I don't need no like terms that I can combine in there. So let's distribute this 6. That gives me 6y, and then 6 times 4 gives me plus 24. Okay, this starts to look familiar now. So the first thing we're going to do is get rid of the adding and subtracting. So here's my 6y. I'm going to leave that alone for a moment. And I'm going to get rid of adding 24 by subtracting 24 from both sides. So these 24's cancel each other out. Positive 24, negative 24. That leaves me with 6y. On the right side, I have negative 18 minus 24. I could think about this as, because this is a lot of negatives, minus negative 18 plus a negative 24 if you wanted to. That gives me adding two negatives, which is friendlier to think about. So I have negative 42 over here on the right. Now I'm left with my last step, which I have to divide. I'm multiplying by 6. The opposite of that is dividing by 6. divide both sides by 6, and we get y equals negative 7. So again, we're going to save that multiplying and dividing until the very last step. We're going to get rid of our parentheses, any exponents if they should show up, then deal with adding and subtracting on both sides, dealing with our multiplication and our division as our last step.